Hello and welcome back. Okay, what I've got here is an Xbox adaptive controller. Quite interesting, these. This is a regular Xbox controller that you're probably familiar with, and these buttons are nice and convenient for my hands, but some people can struggle with this. And so Microsoft created this, the adaptive controller, and the idea is rather than being a one-size-fits-all controller, it's designed to be adaptive. And the idea is instead of having a fixed configuration, you've got a basic set of buttons on here, and then you've got connectors at the back for all the other buttons and functions. And there's a USB at the side as well, and this side. And so the idea is you can plug lots of custom peripherals in here and build a accessibility controller that's suitable for a specific person and purpose. So I've got a couple of peripherals for it here. So we've got some basic buttons on here, but then this one I've plugged in has gone into button 4. It's labelled Y here. Got another smaller button I'll plug into X. But I've only got 2 buttons. I've actually borrowed this from work. So we have one of these for some development and testing, because it's sometimes necessary to take this into account when you're putting together the configuration options for a game. Now what I'd like to do though is make some new buttons, and making giant buttons this kind of size is not necessarily straightforward. Firstly, we need to understand what the connection behind this is, and this is literally just a standard mono headphone type connector, and I happen to know that we literally just join those conductors together and that's the button pushed. The analog ones are a little bit more complex. Okay, so I need one of these connectors. Now you might remember from a mailbag a while back I had bought a couple of these. I actually bought them for this project, but it's been a long time coming. There we go. There's button 4 being activated. And my idea was that I could just cut these cables in 2 and have the wiring for 2 of them, but this is actually a bit short. I think I might have to do some modifications on that. Other thing I need to think about is what I'm going to use for a switch. Okay, I've got 3 micro switches. You'll probably see me use these on the CPU build just as regular buttons. Now I'd have to take the levers off these or buy some without the levers, but they've got quite a bit of motion and a big clunky feel there. I quite like that. And these ones are somewhere in between. I think these are just too big, and the travel on these is not very far at all. So let's go for the middle one. I'd rather these without the lever, but I have discovered in the past that you can just pull the lever component off. I've still got a good motion on it. Okay, so I found some slightly longer bits of wire. It's a little bit more flexible with this stuff as well. Hopefully my wire cutters can handle these thinner bits. That's interesting, there's actually 3 conductors in here. Don't want it to be anything like that long. At a rough guess, one of these is unused. Both green and red connected to the tip, and black is connected there. Interesting. It's probably going to be easier if we just trim the green one. Microscope is probably more bother than it's worth here. So now I need to connect these wires to the switches. Now, is it better to tin the switches or not? Let's give it a go. Let's try doing this one without tinning it. I don't think in these cases with nice fresh contacts it's going to make much difference. In hindsight, it would probably have been better to just order connectors and solder them on. I thought I was being clever ordering these wires. Heat shrink around a soldering iron is really difficult to deal with because it has a habit of shrinking when you don't want it to. Probably some technique to doing this I don't know about. Right, I need the hot air gun. Right, let's give our highly advanced electronics a test. Well, our buttons work. I know what you're thinking. This is not the same level of circuitry you're used to me making on this channel, but now we've got our switches. Let's see what we can do about 3D printing a nice big button. Okay, this is the first little bit I've designed. Now this matches the face shape of the micro switch. Now for the holes, what I've done is I've taken cylinders and cut them at 45 degrees, because that should give me just a little bit of purchase on the micro switch, but it should be able to print without needing any extra support. Okay, let's have a look. Right, that does grip the button quite well. So I'm going to reflect this over, miss the bottom out, and need to build up the sides a little bit with something that we can clamp. Always worth remeasuring because the 3D printed parts never quite come out at the same size. It's 11.52. Okay, now this is the lower portion, so you can see the embedded section designed to grip the micro switch here. Here is the cable recess. You can see the bottom portion of this I've made in a circular form, but the upper half is done as octagon profile. Once again, this allows me to print this without using any support material. That is pretty cool. Okay, yeah. That button holds in there quite nicely. I just know if I got these holes the right size. Okay, it's a nice tight fit. Let's try a different way of getting this started. A cable retention has traditionally been a bit of an afterthought for me, but I did cut this hole in for a cable tie. Now, I've deliberately picked screws that are much longer than I need here. Pretty sure I've got some shorter ones. What I want to do is design the top so it sits on as a shell here, has a protrusion to push the button, but then has a lip that will sit down underneath here. So it's going to have the same freeway symmetry, so I can put it on and rotate it into place to catch under the lip. But then we need to stop it from rotating. So I figure if I have a descending bit that will actually get trapped between these screws, then we take the screws out, put the top in place, twist it, and then put the screws in, and we've got all in one piece held together just by those two screws. And that'd be pretty cool. But I'm really pleased with this so far. Now the button stands very slightly proud of this assembly, and obviously the button needs to be shorter than the surface to top because it's not going to go all the way down to the bottom. But so it's roughly 16mm up to the base of where the button is. Let's go 18 all the way to the top, and then we'll build the upper surface on top of that. So that's the outer wall of the button. Now this lip, that goes from 28 to 30mm out from the edge. I appreciate this would have been easier if I'd just made this 2mm tool to start with. Right, so this is the lip that basically retains the button onto the base. I'm going to cut that into the 3 sections as well. So the idea is this sits on top and then you rotate it 1/6 of a turn into its correct location. Right, so this is the outer skirt, and that needs to be cut to this height with a little bit of a gap for the button to be pushed down. But now this lip needs to be sliced up like that. And actually I want to recombine it with the outer after I've chopped it, or the centering isn't going to put it where I want. Right, now the screws are going to come up here pretty much to the point of being aligned with this. But obviously if the button is pushed downwards by just over 1 millimetre, we don't want to have a protrusion up the top which is going to bump into them. But I want to stop the button component from rotating, so I want to put something in between the screws. But that something needs to be able to rotate into this gap for the whole thing to be assembled. I should have 12 mil almost between the screws. Okay, if I put a top on here, that should just about sit above the button. But I actually think it might be good to raise it up a little bit. 1 more millimetre in height. I'm going to guess 1.5 millimetres is enough slack for travel. Now I'm going to be printing this upside down to avoid any support, so I can't do a nice rounded top. That looks quite good. Okay, well I think that might be done. Okay, let's take a look at this. So this little protrusion here is what's supposed to get trapped between the screws, so we're going to need to take one of them back out. That actually seems to feel pretty good. So that's all printed with 3 parts, no support material, and it's just got the 2 screws to hold together. Putting the screw in slightly seems to be the best way of getting these started. This is actually a crimp tool for IDC cables. If I do ever find myself refining this, I will look for a better way of retaining the cable in. I think maybe just some ridges along here might help me clamp the wire right. If you shaped this a bit better, you could probably get away with just the 1 screw. And for this bit, you'd just put a gap in the middle. Right, let's give this a bit of a final test. Oh yeah. So these are designed such that pushing them anywhere around it should create the contact. I'm really happy with these as a first try. Whenever I design 3D printed stuff, I try and do it in as few parts as possible, and I try and avoid support material wherever I can. Okay, I'm really happy with these. I've hit my main goals in that it's only 3 parts for the 3D printing and there's no support material. If you were doing this all one colour, you could just arrange it all on the bed and print them out in one go. If I was to try and refine this further, I'll try and drop this down to 1 screw because that's the one extra bit you need. The other thing I'd probably do is see if I could reduce this gap down to the absolute minimum. I really like these devices. I think it was a nice piece of design work from Microsoft. I'll probably come back to this and maybe try and do some different styles of buttons and maybe do some of the analog stuff as well. I hope you found this interesting. I found it quite enjoyable to do a bit of 3D printing and hopefully something that might be useful in the future. Thanks for watching. Goodbye.